Hello, welcome to the Argo course. My name is Mohammed and I'm very happy to be here. Unfortunately, this is the last topic and the last session of this course. And so far, we became familiar with some different technologies of Argo, such as argo-CD, rollouts, and workflows. And in the previous session, we implemented a CICD pipeline using this stack. We built a Docker image, we pushed the Docker image into a Nexus registry, and we applied all those changes into a Kubernetes cluster to have a new version of the application. So it was very interesting. But this project has a weak point until now. Let's imagine that whenever I modify the source code of my application, after that, I need to run and I need to submit the workflow manually. It means that whenever I modify the source code of my application, I need to build a Docker image, I need to push a Docker image, and so on. So I have to type argo submit, for example, argo namespace or argo-events. You can also argo or argo-events namespaces, it doesn't matter. And the name of the workflow, for example, workflow.here. Each time, you need to submit your workflow manually. So this is not desirable. The best practice is that whenever I modify the source code of my application and whenever I need to run this workflow, I need a tool to trigger this workflow automatically without any manual operations. Because of that, I decided to add argo-events to this scenario, to this CI/CD pipeline, to solve this problem. But what is argo-events? Argo-events provides a way to trigger workflows based on events that we have within a Kubernetes cluster or external to it. Events can be anything from changes in a Git repository, updates in a database, or custom events defined by users. So I want to use Argo events to trigger our workflow automatically based on some different types of events. So I go to the browser and I type argo events. This is the official documentation of argo events, and it says that argo events is an event-driven workflow automation framework for Kubernetes, which helps you trigger K8s objects, argo workflows, and so on. If I scroll down, these are all the different types of objects that argo events can trigger them. It can trigger argo workflows, can trigger K8s objects, for example, pods, deployments, secrets, config maps, and so on. It can also trigger Kafka messages, Slack notifications, argo rollouts, and so on. In this scenario, I'm going to use argo events to trigger our argo workflows. Very good. Argo events is available in my Kubernetes cluster because I installed this tool already. But if argo events is not available in your cluster, follow the instructions here. First of all, let's click on Operator Manual. First of all, you need to install Argo Events namespace and apply these resources inside this namespace. And then in step 3, deploy the event bus and use this command. Very good. You can also check Getting Started page. If Argo Workflows is not available in your Kubernetes cluster, you need to install it first and then install Argo Events. Because of that, you need to create a namespace named Argo and apply the resources of Argo inside this namespace and then install argo-events. And finally, apply these manifests inside argo-events namespace. You will create some different roles and role bindings inside argo-events namespace. First of all, I want to show you something. I type kubectl get service account -n argo-events. When you install argo-events in your Kubernetes cluster, it will create a service account named operate workflows A. We are going to run all the workflows using the permissions of this service account. Because of that, we are going to grant some permissions to this service account to run the workflows and so on. So you need to apply these roles and role bindings inside argo-events namespace. This is the last step. Okay. If you remember, in the previous session, we used a Nexus repository to store our Docker images. So first of all, let's sign in, admin, and password. And if you remember, we created a repository in the previous session named argo-demo to store our Docker images here. And we have Nginx, and it has 3 possible tags, Alpine and 2 other different tags. These are the tags related to Argo workflows, these 2 different tags. And we built and pushed those Docker images using Argo workflows. And these are workflows UIDs. Very good. And this is the environment of our private GitLab. In this scenario, I'm going to use GitLab instead of GitHub because I want to show you that we can use different sources and there is no difference between them. And also, we have 2 different repositories here. The first repository is argo-config. So if I click on it, you will see all the configurations of this scenario related to Argo stack. The configuration of argo-cd, argo-events, and argo workflows, and also argo-rollouts. Very good. And the second repository is my -app. The Docker file and the source code of our application, all of them are inside this repository. Let's click on it, and you will see Docker file here and also the source code, index.html. We are using Nginx as a very simple application for this scenario, and I'm going to use index.html to replace the content of our web page. So whenever I modify the content of this repository, whenever I push a new commit, whenever I have a new activity in this repository, argo-events will detect those new changes and will run and submit our workflow. For example, if I modify the source code of our application, for example, index.html, argo-events will detect that change and will run our workflow automatically. Very good. Let's go to the note. I'm going to explain about argo-events components. Argo-events components. The first component is event source. The second one is sensor. And the last one is event bus. First of all, let's start with event source. Argo-events supports various event sources, allowing users to define how and when events are generated. For example, we have GitLab event source, GitHub event source, webhook event source, and so on. Event sources often involve integration with external systems or services. For example, a GitLab event source would integrate with a GitLab repository to capture events like code pushes, pull requests, or issues. In fact, we use event sources to connect Argo events to our repository. In this scenario, I'm going to use GitLab repository. Because of that, the type of event source here is GitLab event source. We use GitLab event source to connect Argo events to our GitLab repository. For example, my-app repository. So, if I apply this resource, it means that Argo events will connect to our GitLab repository, such as my-app repository. So whenever I modify the content of this repository, Argo events will detect those changes. Okay? So, event source is responsible to connect Argo events to a specific GitLab repository. In this scenario, I'm going to use my-app repository. So, whenever I push a change, whenever I push a commit inside this repository, Argo events will detect those changes and will run the workflow automatically. Okay. The second component is sensor. Sensors are components that listens for events from event sources and trigger workflows based on those events. Sensors are responsible for mapping incoming events to specific workflow triggers. So, event source will connect Argo events to GitLab repository. Okay, after that, I make a change inside this repository. In this situation, sensor component will responsible to trigger our workflow. Okay? The responsible of event source is connecting these two objects, and the responsibility of sensor is trigger the workflow. Okay. The last component is event bus. The event bus acts as the transport layer of Argo events by connecting the event sources and sensors. Okay, these are all the components. These are the important components of Argo events. Okay, let's check the configurations of this scenario to see how them work. First of all, let's go to the private GitLab environment, and I want to clone these two different repositories. First of all, clone argo-config repository. I create a directory here named argo-demo, for example. Argo-demo, and I want to clone these repositories here. Git clone argo-config, and let's clone another repository too, my-app repository. Okay, I clone this repository too. Git clone my-app repository. Very good. Let's go to VS Code, and I click on open folder and I type argo demo and open, and very good. These are the repositories of this scenario, argo-config and my-app. First of all, let's go to argo-config directory and let's go to argo-events. Okay. We have two important files here, event sensor and event source. First of all, let's start with event source. This is so important. Please pay attention that if we apply event source, in our Kubernetes cluster, it will create 3 different objects for us. The first object that event source will create is a Kubernetes pod related to event source. The second object is a Kubernetes service. And the last one is a Gitlab webhook. These are the objects that event source will create when I apply our event source. But what is Gitlab webhook? First of all, let's go to my-app repository. I click on settings and webhooks. I click on add new webhook. Okay. Webhooks are custom HTTP callbacks that you define. They're usually triggered by an event, such as pushing code to a repository or posting a comment on an issue. When the event occurs, the source app makes an HTTP request to the URL configured for the webhook. For example, if you have experience working with Jenkins, you should know that you can provide the URL of your Jenkins job here, for example, and whenever you make a change in your repository, this webhook will trigger your Jenkins job, for example. And our Argo events and the event source has a URL. Our event source has a URL. As I said earlier, event source will create a Kubernetes service, and its type is cluster IP. Okay? Its type is cluster IP. And as you know, cluster IP service is not reachable from outside of the Kubernetes cluster. One of the solutions to make our service reachable from outside of the Kubernetes cluster is using ingress. So in this scenario, I'm going to create an ingress to access to our event source SVC. So this will be the URL of our ingress for the event source service. Okay? Very good. Let's go to event source.yaml. The first object that we have here is a Kubernetes secret. As you know, event source will create a webhook for my-app repository. So it needs some permissions to create this webhook. Because of that, we need access tokens for event source. So let's add a token, and we can create access tokens per project. I click on add new token, and its name will be like this, my-app-token. It has no expiration date and select a role, for example, maintainer, select scopes, and API is enough, and create project access token. This is the token of my-app repository. So I type echo-n, this access token, and pipe it to base 64. And this is the base 64 encoded value of our access token. And I will replace it. So event source will use this token, will use this access token to connect to my-app repository to create a webhook. Okay. The second object is event source. As you can see, its kind is event source. Its name is CI. And event source, I want event source to be applied in argo-events namespace. As I said earlier, one of the objects that event source will create is a Kubernetes service. So this is the information about the service, port and target port. But what about the name of the service? It's so important. What about the name of the service that our event source will create? The name of the service will be like this. The first part of its name will be event source name. Event source name dash event source dash svc. The name of the event source in this example is CI. So its name will be like this. CI dash event source dash svc. This will be the name of the service that event source will create. So when you want to create an ingress for your backend service, you can use this name. Okay? So it has three parts. The first part is event source name. The second part is event source, and the last part is SVC. Okay. As I said earlier, I'm using GitLab event source, and its name is argo-demo. And this is the project ID of my-app GitLab repository. As I said earlier, event source is responsible to connect Argo events to a specific repository. And I'm going to integrate Argo events with my-app repository. And the project ID of my-app repository is 35. So if I click on my-app repository, you can see that the project ID of my-app repo is 35. Okay. Event source will create a webhook, as I said previously. Its endpoint will be /push. Its port is this, and the URL is http://argo.events. You can create this URL based on your needs. It doesn't matter. This is so important that this URL must be reachable from inside your GitLab server. Okay? And events is push events. Whenever you make a push event in your GitLab repository, Argo events will detect those changes. And it will create that access token that we created to create that webhook. GitLab-access. This is the secret here, GitLab-access. It will use this access token to create that webhook. Enable SSL verification for the webhook is false. And this is the URL of our GitLab, or of our private GitLab. For example, the URL of my private GitLab is gitlab.isc. Change it based on your private GitLab. And delete hook on finish. When I delete this event source, that webhook will be deleted too from inside our GitLab. Okay? And also, as I said previously, event source will create a service and its type is cluster IP. It means that it's not reachable from outside of the Kubernetes cluster. Because of that, we need an ingress to access to this service from outside of the Kubernetes cluster. So this the third object that I'm going to use in this file is ingress. I'm going to create an ingress, and its backend is the cluster IP service. CI event source svc. This is the prefix that I talked about it. CI-event source svc. This is the name of the event source event source svc. And its port is this. And the host is argo.events. Argo.events points to my local host. This is my Kubernetes cluster, okay? So when I type ping argo.events, it will return the local host because argo.events is available in my etc hosts. You can add your argo.events in your etc host and it will return your local host. Argo.events as a URL must be reachable from inside of our GitLab server. So I type ping gitlab.isc. Its IP address is this. So let's SSH to GitLab server. I type etc hosts. And as you can see, argo.events is available in the etc hosts of my GitLab server. So when I type ping argo.events, it returns this message. It means that argo.events is reachable from inside of my GitLab server. So this URL must be reachable from inside your GitLab server. This is so important. Okay, it was about event source. The next file is event-sensor. As I said earlier, we are going to run all the workflows with the permissions of operate workflows a service account. Because of that, it needs some permissions to run the workflows. So you need to provide some different roles and role bindings to make this work. Okay, so you can use these lines here. The name of the sensor is CI, and I want to apply this sensor inside argo-events namespace. And I'm going to run the workflows with the permissions of operate workflows a service account. And also we have a block here called dependencies. Its name is not important. You can change it if you want. It doesn't matter. But it has other two different things that are so important. The first one is event source name. In the fact, I'm going to connect this event sensor to event source. I'm going to connect these two different components, event source and event sensor. So this is the name of the event source. If I go to eventsource.yaml, you can see that its name is CI. So event source name is CI. But what about event name? Each event source can have multiple events. But in this scenario and in this example, we have a single event named argo-demo. This is the type of event source and this is the name of the event, argo-demo. So the name of the event or event name is argo-demo. In the fact, we use dependencies block to connect sensor to our event source. And triggers block, as I said earlier, sensor is responsible to trigger our object. It can be argo-workflows, it can be a pod, a deployment, secret, a config map, or any other things. In this example, sensor is responsible to submit our Argo workflow. And this is the workflow that I'm going to use. We talked about this workflow in the previous session. This workflow is responsible to build my Docker image first. As you can see, its first task is clone repo task. Clone-repo. It will clone these two repositories, my-app repository and argo-config repository. It will clone these two repositories first as its first task. And then it will build the Docker image and push the Docker image into our Nexus registry. If you are not familiar with this workflow, you can watch the previous video. I talked about this workflow in the previous session. But for now, you should know that the first task of the workflow is clone repo. It needs to clone our two repositories, my app and argo-config. Then it will build our Docker image, and then it will push the Docker image into Nexus registry. And also, the last task of this workflow is update-manifest. It needs to access to our rollouts manifest and replace its image with the new version of our application. For example, the image field of our rollouts manifest points to the previous version. Argo workflows will modify its image and replace it with the new version of the application. So these are the tasks that workflow will need to do. And very good. So sensor is responsible to trigger our workflow. And also, I need to provide the username and the access token for my two different repositories, because for my-app repository, it needs to create a webhook, and for my argo-config repository, it will need to update the rollouts manifest. So I need to provide username and token for these two different repositories. We created an access token for my-app repository. This is the access token for my-app repository. So I change it with this. Very good. And let's go to create an access token for argo-config repository. I click on argo-config and I click on access tokens. Add new token. Argo-config-token. Very good. I copy the content and paste it here. Very, very good. So this is the IP address of my Nexus registry, and everything is good here. Okay. The event sensor and the event source. Very good. Okay. Let's go to argo-cd, and we have our argo-cd application here. Okay. It will apply our application inside argo-demo namespace. But what about argo-rollouts? We have an ingress for the rollouts, and our application will be accessible and will be reachable using this URL, argo.demo. And the rollouts manifest, I'm using canary strategy for our scenario. First of all, it will switch to the new version of the application using 20% of the traffic. So 20% of the traffic is routed to the new version of the application. And then we have a pause with no duration set. It means that I need to unpause the rollouts manually. And after that, 40%, 60%, and 80%, all the traffic will be routed to the new version of the application. And this is the image of my rollouts manifest. Let's check that this image is available in my Nexus registry or not. I click on Nginx and tags. And yes, this image is available in my Nexus registry and everything is good. So, okay. Very, very good. I want to show you something. First of all, if you are using Docker as your container runtime, you need to add your Nexus registry to your etc docker daemon JSON. So if I type etc docker daemon JSON, you will see my insecure registry inside this JSON file. Very good. And if you are using containerd, you have to add your insecure registry to your config.toml. I'm using kind for my Kubernetes cluster. So if I go to kind control plane if I go to kind control plane container, you will see that I'm using containerd inside my Kubernetes cluster, etc containerd config.toml. So if you are using containerd as your container runtime, you need to add your private registry inside this file. And you need to add these 4 lines to the end of your file to point to your insecure private registry here. Very good. In this scenario, I'm going to use workflows artifacts. If you are going to use workflows artifacts, you need to set up an artifact repository such as min.io. So if I type kubectl get config map -n argo-events, one of these config maps is artifact-repository. So argo-workflows will use this config map to connect to my artifact repository min.io to store my artifacts. So if I go to sensor, argo-events, and event sensor, you will see that the artifact repository ref is the config map artifact-repository. It means that argo-workflows will use this config map to connect to min.io to store the workflows artifacts. Very good. Let's start with this scenario. I go to argo-demo and I go to argo-config and argo-cd and I apply kubectl apply-f argo-app.yam-n argo-cd. You need to apply your argo-cd application inside argo-cd namespace. So this application has been created inside argo-cd application. So when I go to argo-cd dashboard here, this application has been deployed in my Kubernetes cluster. As I said earlier, you can access to your application using this URL, argo.demo. So I type http argo.demo. Welcome to my website, version 2.2.0. This is my application. So when I type kubectl get pod-n argo-demo, these are the replicas of my application. Very good. If you want to access to your argo-rollouts dashboard, you can type kubectl argo-rollouts dashboard. I copy the link and paste it here. This is the dashboard of my argo rollouts, and we are in revision 1. Very good. As I said earlier, when I go to argo-events namespace, and when I apply event-source, it will create 3 different objects. But for now, when I type kubectl get pod-n argo-events, these are the pods that are available in argo-events namespace. So if I type kubectl get svc, these are the services, and when I go to my -app repository, you will see that there is no webhooks enabled here right now. So let's go to apply my event source. kubectl apply-event source. No, I need to, okay. 3 different objects created: a Kubernetes secret, event source, and ingress. So if I type kubectl get pod-n argo-events, you can see that one pod is creating. The Kubernetes pod is creating. So as I said earlier, a Kubernetes pod. And its status is running now. Let's go to SVC. Yes, ci-event source.svc has been created, and its type is cluster IP. This is the second object that event source created. The last object was Gitlab webhook. So when I refresh this page, we will see a Gitlab webhook. I refresh the page. And yes, a webhook has been created using event source. Let's click on edit. And as you can see here, its URL is this, argo-events/push, and push branches is on wildcard. I click on all branches, and okay, save changes. So This URL has been created by event source. Very, very good. So 3 different objects created using event source. A Kubernetes pod, a Kubernetes service, and a Gitlab webhook. And we can access to this service using the ingress that we created. So if I type kubectl get ingress -n argo-events, you can access to your backend service using this ingress. Very good. So at this moment, whenever I make a change inside my -app repository, a workflow will be created here, and we will see that workflow here. Okay? Let's test it. As you can see, we are in version 2.0. I want to change it to 2.1. Okay? So let's go to my -app repository first. I click on index.html and I click on edit and edit single file. And I change welcome to my website version 2.0 to version 2.1. Okay, let's commit changes. Okay, as you can see, there is no workflows running because another file needs to apply. The another file is event sensor. So I type kubectl apply -f event sensor -n argo events. Very good. So let's go to index.html again and change the file. And I want to change version 2.1 to version 2. For example, 2. Let's commit changes. Very good. And as you can see, one workflow is running. I delete the previous workflow, and this is the new workflow that is running. Its first task is clone repo task. Clone these 2 different repositories, my-app and argo-config repository. Its second task is building the Docker image and pushing the Docker image into Nexus registry. Okay, I want to pause the video because this process takes a few minutes, and I will come back soon. Okay, argo-workflows built the Docker image and pushed the Docker image into Nexus registry, and very good. And the last task is update manifest task, and the update manifest related to argo-rollouts. And very good. Image.tag has been changed to something like this. Argo-workflows updated the rollouts manifest to point to the new version of the application. First of all, let's go to Nexus registry. I refresh this page first. And you will see a new tag here. Yes, this is the new tag that argo-workflows built and pushed here. Okay? And also, if I go to my argo-config repository, I click on argo-config, And as you can see here, image.tag has been changed to something like this. This is the activity that argo-workflows had. And if I click on argo-rollouts, and if I click on Nginx rollouts, you will see that the rollouts manifest has been changed to something like this using argo-workflows. Very, very good. Argo-CD will refresh the new activity after 3 minutes. You need to wait for 3 minutes or refresh this page manually. Very good. So the new replica set has been created. When I go to argo.demo and if I refresh this page multiple times, you will see that 20% of the traffic is routed to the new version, 2.2. Let's refresh it multiple times. Yeah. Welcome to my website version 2.2. And if I refresh this page multiple times, you will see that 20% of traffic is routed to the new version. And one replica is in revision 2. If you want to switch to the new version of the application, you need to unpause the rollouts because in step 2, we have pause with no duration. So I type kubectl argo rollouts promote nginx rollouts n argo demo. And the rollouts has been promoted. And as you can see, we have 2 different replicas in revision 1. We need to wait until the end, and after that, we will be in the new version of the application. Okay, so if I refresh this page multiple times, we see 2.0 as well as 2.2. I'm waiting for the final result of this promotion. And all the traffic will be routed to the new version of the application after 1 minute. I'm waiting for 1 minute. Okay, we have 5 replicas in revision 2 right now, and all the traffic is routed to the new version. So we won't see 2.0. If I refresh this page multiple times, you can see that all the traffic is routed to welcome to my website version 2.2. For another example, let's change it to 3.0. So I go to Gitlab and go to my-app repository and index.html. Edit. And I'm going to change welcome to my website version 2.2 to version 3.0. Okay? I commit this change and I'm going to wait for the new workflow here. Yes, the workflow is running right now because I made a change in my-app repository. So let's wait for the final result of this workflow. Because of that, I paused the video until the final result of this workflow. Okay, workflows built the Docker image and pushed the Docker image, and I'm waiting for the final result of the last task, update manifest task. Okay, done. Image the tag has been changed to something like this, and very good. And also, if I go to Nexus registry and if I refresh this page one another time, and if I go to Nginx tags, we will see another tag here. And let's go to argo-cd, wait for 3 minutes, or refresh the page, refresh your argo-cd application. Very good. So if I refresh this page, 20% of traffic is routed to the new version, 3.0. Yeah. 3.0. And we are in revision 3, and we have 1 replicas in revision 3. And in step 2, we have paused with no pause duration. So I promoted the rollouts manually, and we need to wait for the final result. And after that, all the traffic will be routed to the new version of the application. But right now we have 3 replicas in revision 3. So if I refresh this page multiple times, 60% of traffic is routed to the new version of the application. 3 replicas, and right now 4 replicas. And after 1 minute, all the traffic, and 5 replicas, all the traffic will be routed to the new version of the application. Okay, it was about argo-events. So using argo-events, you don't need to submit your workflow manually each time you modify the source code of your application. And it can help you a lot to trigger your objects. This object can be argo workflow, which can be a pod, can be a deployment, can be a secret config map, or Slack notification, argo rollouts, or any other things. Okay, we implemented a very interesting CI/CD pipeline using Argo Stack, including argo-cd, argo-rollouts, argo-workflows, and argo-events. And it was very interesting. I hope this course has been helpful for you, and I apologize if the quality of the course was low. And you can also contribute on our GitHub repository of this course if you want. This is the repository of this course, argo-cd-tutorial, and you can also add your own CI/CD pipelines, add your own workflows, add your own argo-cd applications, projects, and any other things if you want. And also, I have another personal repository named CICD with Argo Stack. This is my personal repository. You can check its README, and also you can follow the instructions of this repository to run your CI/CD pipelines as I did in this session. Very good. Please let me know your feedback, and I wish you all the best, and goodbye.